Okay, the key idea behind Surds, alright, is very simple. Okay, is to make sure there are no root terms at the denominator. Alright, so we need to get rid of any root term at the denominator. So if I want to get rid of the root term at the denominator, I need to use this thing called rationalize. Alright, rationalize. I'm going to write down the word. I need to rationalize. But how do I rationalize? I will need to multiply by the conjugate. Alright, I will need to multiply by the conjugate. So, in question 1, if I want to multiply by the conjugate, Zuo Hong, can you tell me what's the conjugate in question 1?
Square root 2, square root 2.
Very good. So, I multiply by root 2 over root 2. So, very quickly, I will just numerator multiply by numerator, denominator multiply by denominator. So, I have 3 root 2. Square root 2 times square root 2, Zuo Hong, what do you get?
2.
2, yes. Alright, you can use a calculator even if you want to. Alright, so if you only have one root term at the denominator, it's very straightforward. Alright, thank you, Zuo Hong. So, however, in part 2, Diana, can you tell me what is the conjugate in part 2?
1 plus square root 2.
Thank you very much. Alright, if there are two terms, the conjugate will be the opposite sign of what is given at the original denominator. Since the original one is minus, I will need to multiply by the one with plus, like what Diana said. Okay, do the same for numerator and denominator, and you do likewise. Numerator times numerator, denominator times denominator. So in this case, I'll just do a quick one. Alright, take note, at the bottom you can make use of your difference of square. So in this case, 3 plus 3 root 2 divide by 1 minus 2. Alright, in this case, 1 minus 2 is actually negative 1. So when I simplify, I'll get negative 3 minus 3 root 2. Okay, assuming you can do the simple Surds in part 1. Okay, let us take a look at part 2 right now. They say, hence or otherwise, find the value, alright, of P and Q in that equation there. Hence or otherwise. I say before already, whenever you see the word hence, likely it's an easier method. Unless you cannot see, then die no choice, you use your own method. Okay, so if possible, I like to use the method where they prescribe is possible. Okay, how to get started? Okay, if you can see, this whole fraction on the left side is exactly the same as the question in part 1. Am I right? So, very simple. What am I going to do? I'm just going to use the answer I have for part 1 and do my part 2. Okay? So this one I think everybody knows. Because the fraction is exactly the same. Alright? Because the fraction is exact. Okay, let me. Okay, you see the fraction now. Let me do a box in case you cannot see. You see that the two fractions are the same. And because of the word hence, I'm going to use the answer now. Okay, so rather than rewriting this whole question here, okay, the square box in black, I'm going to use my answer now in part 1. And then write down the question. By just doing this, you obtain your first mark already. Okay, now we are stuck. Anyone?
Simultaneous.
Ming Xue, what gave you the idea of simultaneous? Can you share with us?
You derive two equations from this thing.
What are the two equations?
PQ minus 5 equals to negative 11.
Okay, why do you say that?
Is the constant on right side equals constant left side.
Okay, very good. Alright, I like what Ming Xue just said. Alright, the PQ and the minus 5, alright, is a constant. is the whole number. So equate PQ minus 5 is equal to negative 11. This is your first equation. Alright, Mingxue, very good. Next, that is your first equation. However, notice this one is a surds. These are the terms with surds. So I compare those terms with surds as well. I ignore the square root 5. I will have Q minus P is equal to 5. And this is what Mingxue mean by simultaneous equation. Alright, I like to say this again. This is very important. Why do I say so? A lot of times students can do surd. But then, come to this kind of problem, got solving for two unknowns, suddenly they get stuck. So I like the way Mingxue just mentioned. Remember, compare the constant number with constant. Compare the surds with the surd. And then you solve for simultaneous equation. Alright? Okay, so what you see in part 1 is exactly what Keyfield told us. If you cannot expand cube, it's okay. Do the one for square, then write an additional bracket. But you have to be very careful. Alright? Then, whenever you have surd, notice this surd is not at the denominator. But at the, you see, all these are at the numerator. But whenever the term inside the root term, which is the surd, the number is too big. Remember, you must write it as a multiple of a perfect square. So 50 can be written as 25 times 2. Why? I can square root 25 nicely. Likewise, 20 can be 4 times 5. Alright? Remember, when I say perfect square means you must consider number like 4, 9, 16, 25, 36. Because all these are perfect square. Okay? Okay, that's for part 1. They ask you to go and factorize P cube minus Q cube. You must be able to relate back to your sum and product of roots. Okay? But take note, your sum and product of roots, you are familiar with this one. Sorry, let me use a different color. You are more familiar with this one. When it's plus, this will be plus, this will be minus. Okay? But today, they want the difference of the cube. So you need to use the one in orange, not the one in red.
I think so.
Okay, good idea. Okay, why? Because I gave you the hint just now already. What? You need to write in terms of square root 5. If you don't write square root 5, I think you will die. You cannot do anything. And moreover, I need to make use of this idea because of the word hence. So Alex is correct. Rewrite as square root 5 to the power of 3 minus square root 2 to the power of 3. Okay, the below I write the same. Square root 5 minus square root 2. Okay, now we need to apply the part to this part. How to apply? Use what Seng Fai just told us. Correct? Seng Fai just now was using P and Q. But now we use square root 5 and square root 2. So I'm going to put it in. I replace my P with square root 5. I replace my Q with square root 2. So square root 5 minus square root 2. Because I'm using a factorization method. Then, same thing, bracket, square root 5 square is 5. Square root 2 square is 2. Then, plus square root 5 times square root 2. I have square root 10. Over. Hey, something magical is going to happen already. What's going to happen? Can anyone tell me? Alright, so the idea is very simple. Okay, first thing, they give you a few hints. Alright, hints like you need to write in terms of square root. And I was glad that just now Seng Fai, he was able to tell us we can use our sum and product of roots to do our factorization for P cube minus Q cube. Then Alex helped us to simplify the question. Alright, why? Because if you write in terms of power 3 over 2 or power half, you cannot go anywhere. So Alex told us to change it to square root 5. But with the power 3, I link it together. I do my factorization. Okay, use the answer. Then I will simplify. Alright?